Okay, so thanks for coming. I know it's a Friday night, but welcome to our review. So exam one information, this is all found on our Canvas page, just under exam one information and practice. So you are allowed to bring one page of your handmade notes, just make them yourself. It also helps you study. So you are not allowed a calculator during your week one exam, and then the content will primarily focus on weeks 2 through 4. It might include a little bit of one. Just keep in mind that you have 80 minutes to take the exam, and if you go over, you will be penalized. 1 point every 5 minutes you go over, and it should take you about 60 minutes to do, but you are given 80. So regarding our topics, these are some of the topics that we will cover. The full list is on Canvas. This is a summarized list, and the goal is to get through most of these today, at least a little bit. All right, so really quickly, I would love if you guys are able to try the annotate button. Sometimes it shows up as a little pencil in the corner of your screen, or sometimes it'll show up on the bar, but you should be able to draw on the screen like I'm doing here. Can you guys all see that? Awesome. Thanks, Jake. And then hopefully that works, because I'd love to prompt you guys to draw on the screen so that way we can get some engagement. And then if we have enough people for breakout rooms, we'll go ahead and do those. And that'd be great if you guys could talk during them. And then sometimes I'll ask you guys to use the reaction feature. So give me a thumbs up or a thumbs down if you understand something, if you got the right answer. And then, yeah, feel free to talk whenever you'd like. I prompt you guys. I'd love participation. Or if you don't have a mic, go ahead and answer in chat. Awesome. Looks like Ashton figured it out as well. I'm going to go ahead and move on with our first topic. So linear functions and equations. Hopefully everyone knows and is very fluent in y equals mx plus b, where y is our output, and then x is our input or independent variable, and then b represents our y-intercept, where it's the y value when x equals 0. Hopefully you're familiar with your slope formula, your rise over run, your y1, your change in y over your change in x, because we'll be doing that a lot, and that'll definitely be on the exam. All right, so I think we have enough to do a quick breakout room. So really quickly, go ahead and take a picture of the screen so that we have the question. But I want you guys with a slope of 5/2 and a y-intercept of 2. What does your equation look like? And then see if you can graph it. I'll go ahead and give you guys 3 minutes. And then, yeah, those are open now. Yeah. All right, welcome back, you guys. How did it go? Were you able to graph it?
Yeah, we were. Are we the only two in this
Yeah,
review session?
looks
Oh,
like I do know that like 10 people kind of already took it, so
oh, okay.
those are like the more like proactive ones. And then this is being recorded, so they'll probably watch
Okay,
it later.
perfect.
All right, so is this what you guys got?
Yes, that's what I got.
Great. Awesome. Hopefully no troubles on this one. I don't know if you guys took a look at Wednesdays. It was a little bit different where I gave you the x-intercept instead. So hopefully you guys are able to figure that one out as well. And if not, I prompt you to go look at it, see if you can figure it out.
Okay.
It's a little bit harder. All right, so it looks like you guys got it. Fantastic. And then how'd you guys feel?
I feel pretty good about the y equals mx plus b.
Great. Awesome. So let's go ahead and move on. Hopefully you guys are both able to do the annotate button. So I have this function, f of x is absolute value of negative 2x plus 1. And then you're able to solve that and annotate it. That'd be great. I'm going to see if I can get mine pulled up as well so I can annotate easier.
Okay. Just gonna write it down.
Yeah, I'll go ahead and do the bottom one just in this corner.
Okay.
I'll go ahead and do the top one.
Cool. And then if you can't annotate, you can just tell me what you get as well.
Oh, okay.
Or you can just write it straight in the box, yeah.
Oh, there we go. Now it's working. Oh, that's a horrible 3.
It works. All right, wonderful. Now we're gonna go ahead and take all of these numbers and then we are gonna practice graphing it. So the math looks great, you guys. Let's go ahead and graph it. So whatever points you wrote, if you'd like to also put them on the plot, that'd be awesome. So I'll do the bottom one down. Do this one.
I'll do the top 2. I can't do a circle.
No worries. There's like a shape button too on the annotate, so you can like get a perfect circle too.
Wait, where is that?
I believe it's where you press where you pencil and then you can choose a different shape.
Oh, sweet. Okay.
Yeah, what you're learning today.
Oh, it's tiny.
So pretty.
Oh. -1.
All right, we've got all of our points, so I'll go ahead and connect them. And then knowing the function of absolute values is always like a sort of V shape, right? Does this look like what we would expect?
Yes.
Yay. All right. Great job. Be sure you know how to graph functions. It's like you guys are pretty good at it. All right, so I was supposed to have that transition, but that's okay. The domain and range. Do you guys remember?
Review.
Yeah. Yeah. So our domain is our x's, right?
Mhm.
Yes.
And then our range is the span of y's. So I went ahead and gave you the answer, but does that make sense? That we would have a range of like bracket 1 to infinity for our y?
Yeah.
Yes.
Okay, awesome. All right, we'll go ahead and move on to the definition of a function. Hopefully everyone is familiar with this. I know there are some issues with the quiz, but it's where every domain has exactly one range or every x has exactly one y output. So if we look at figure 5, this first one right here, we can see that every single one of our inputs has exactly one output. So every x has exactly one y. But in our second figure, figure 6, we have where 0 has one y, and then 3 has 1y, but then our 6 has 2y's. So this right here would make it so that we do not have a function. So our second figure's like equation is not a function. So then continuing on to that, we can do something called a vertical line test. Hopefully this is familiar to Alex, but it's where we take whatever function we have, we graph it, and then we can run a vertical line. So like x equals anything. And then if we can run it through the entire equation, so like from here, there's only one point where we intersect with the line. Here we only have one y, right? Every single place here, we only have one y. Then we know it's a function. So this one passes the vertical line test. And then we have the second one that does not pass the vertical line test, because at every point of our function in orange, we have multiple solutions of y, right? So this line has two y's. So like say this is x equals 3, we've got two different y's. So because of this, it does not pass the vertical line test, and we do not have a function. Any questions on the vertical line test?
No.
All right. So really quickly, either if your camera's on, give me a thumbs up, or otherwise you can use reactions. Is this a function? Got one no. We got a circle no. Awesome. Great. Yeah, it's not a function because there's multiple points where they touch. Right. So great job. And then we've got one more. Is this one a function?
Yes.
Also, yes.
Cool. Great job. And yeah, because we have every single point only has one solution, every x only has one y. All right. And then really quickly, we'll go over f of x notation. I've heard that this is quite confusing for people, but every time I say f of x, I mean this here, right? So f of x represents our output and x represents our input. You've already been doing this, like where f of x, like with your y equals mx plus b, y is technically an f of x function. So f of x notation allows us to like transform on x. So in this case, hopefully this is familiar, but I'll go ahead and give you an example. So if we have a function, f of x is equal to 2x plus 3, and then we change it into f of 3x, where every single x we have, we replace it with x minus 3. So I've done this here. The thing is that we have to remember to FOIL. So we need to FOIL this 2 out to the x and this 2 out to the 3. So then we get 2x minus 6 plus 3. That would be our f of x minus 3 function, right? And we can simplify this further. So when you look at it graphed, this is the green one is our original one, and then the black one is our f of x minus 3. So our graph went down 6 units, right? So we started from here, and then it's the exact same slope, but we've moved everything down by 6 units. So can anyone kind of guess why? Or see the method of why we did that?
Just because you had the y-intercept would have moved down 6 points because of 2 times -3.
Yeah, perfect. So just keep that in mind that whenever you FOIL and we only have like an x minus 3 in there, we just change the intercept by what we FOILed it by. Awesome, that's great. So yeah, the slope stays the same and your y-intercept decreases by 6. Really quickly, we're going to go over solving inequalities. So just some inequality rules that I recommend having on your sheet. Whenever you add and subtract, you must do the same on both sides, so that way the inequality sign stays the same way it's facing. Multiplying and dividing by a positive number, same thing. Every time you must do it to you must do the same thing to both sides, and then that'll make sure your inequality sign remains the same. And then this is the big one. Remember, when you're multiplying or dividing by a negative number, the inequality is reversed. So you have to flip it in order to make that statement true. So here's a quick example. So if we were to solve for x, we would first want to add 5 to both sides. We'd get 2x is less than 12. And then we want to divide both sides by 2. And then we'll get 12 over 2. Or sorry, we'll get x over 2 divided by 2. 2x divided by 2 is less than 12 over 2, which means x is less than 6. So then hopefully we are able to do this because there's only one group. I'll go ahead and break you guys out and just assign one person to kind of work it out. I'll give you guys 3 minutes again to solve for x. All right, welcome back. What'd you guys get?
I got x is less than or equal to 6 over 7. I don't know if that's right because he got something different. I don't know if I did it right.
What'd you get, Ashton?
I got x is less than 5.
Let's see. Oh,
So I dropped the equal sign.
All right. So what was your guys' first step?
So I distributed first.
Same.
Okay. Cool. That's
So-
one way to do it. Another easier way to do it is to multiply both sides by the reciprocal of your fraction. So then you can just get rid of the fraction, right?
Oh, right. I always forget
Oh.
to do that.
Yeah, no worries. So we can just do that really quickly. And then what do I get on the right side?
I think it was 12 over, or no, it would be
Yeah,
12.
12 over 2, which is 6, right?
Yes.
Cool. And then we just add 1 to both sides and get x is less than
That makes sense. I was overcomplicating it.
yeah, it's okay. I was doing that last night or the other night as well. But we could foil it if you guys wanted to go through it. You'll get the same answer.
Sorry,
Would you-
what was that?
If you wanted to foil it, we could as well. Do you want me to go through that?
Foil it? Oh,
Yeah.
foil. First, out, inner. Yeah.
Yeah. We
Sure.
can do that too. 2/3 x minus 1 is less than or equal to 4. We bring that to both terms. We get 2/3 x minus 2/3 is equal to 4. So then what would our next step be?
Subtract 2/3.
We would add 2/3, right?
Oh, add 2/3, right? Sorry.
Yes.
Cool.
Oh, I did the same thing.
Then
Then you have to make the 4.
where I didn't know because like we haven't
Okay.
seen that in the textbook yet or anything, and or on answers, and every time I try to put in like a mixed number, it wouldn't count it. And so that's why I haven't done that yet.
Cool. So then did you just make it like the
Yeah, I times
The
4 by
fraction.
3, so it's 12 over 3. Or yeah, 12 over 3. So that's what I did.
it's 14, right? Because we have if we wanted
Well, it
4,
would be 14 after 14 over 3, but
Right.
I was just saying that's what I did. Yeah. Sorry.
Cool. So this is 14 over 3 less than or equal to 2/3 x. And then now you multiply by the reciprocal, right? So we
Yes.
do that first step again. 3 over 2, 3 over 2. So what do we get? So we can either think of multiplying all the way across,
Right.
or we can also do the
Uh,
cross. I don't know if you
42?
get that.
42 over 6. Is that 14 times 3? Or
It's
42?
14 times 2, which is
Wait,
Yeah,
math.
42 over 6.
which simplifies to 7. Okay.
Oh, because 6 times 7. Oh, okay. Yeah.
Yeah. So either way, we can get the same answer. Do you guys both feel good
Okay.
with that? Great.
Now I know what I did wrong. Thank you.
Yes.
Great.
Same.
All right. So now that we have our answer, are you guys able to do it in interval notation? Do you guys remember when you did it with the number line?
Hmm.
So what is our x in our full notation?
It'd be negative infinity.
And then what?
Then 4 in our y spot. Or not 4, 7, sorry.
Cool,
I don't,
7.
I don't know
And
where I
then
got.
do we have an open or closed parentheses?
We have it closed on the 7 and open on the infinity.
All right, beautiful. And then can either of you guys draw it on the number line?
I can do it.
Great.
I can't draw straight.
That's great. All right.
Or we could
Awesome.
also write it like that, right?
Yes. I prefer the closed dots and open dots. I don't see the brackets very often, but that
Yeah,
works
I
as
do
well.
too.
All right.
Wouldn't it be 7 and not 4?
I did 4 again.
Yeah, that's right. It would be at 7.
That's embarrassing.
Happens.
Good, it's Friday night.
Sure.
I'm a little fried. I've been studying all day, so
Yeah, well, I think it's a long weekend, so I'll get some rest, hopefully. All right, this looks great. Good job, you guys. So next we're just going to go over the exponents and some exponent rules. So this is a table I found online, and it goes over all of the different rules that you might see. I recommend putting these on your formula sheet and make sure that you understand the notation. So like where a is your base power, m is an exponent, and then n is a different exponent. Hopefully everyone, both of you guys have seen this. You're familiar.
yes.
Great. So we're gonna go ahead and try this really quickly. I don't think I need to break this out into rooms. I think it's fine. So I'll just go ahead and set 2 minutes and see if you guys are able to solve it.
Perfect.
Able to get everything going.
Yes.
Yeah.
I so is it 1 over a to the 5th b?
I got A5B, or A to the 5th power B.
Yes. So Ethan, what did you do on yours?
Oh, because I thought, right. I always get confused with this. So what I did, I just added the 2 exponents, and then I thought you were supposed to flip it to get rid of the negative exponent. Um, but I forgot that you can also just put a 1 on the bottom.
Yeah, so all we had to do to get rid of this negative exponent is just move this whole thing to the top, and it becomes just b.
Okay.
Yeah, so every time we want to flip just like 1, we just have to move it to the other side of the division line, right?
Right. And I realized that now because the exponents on a weren't negative, so I didn't need to, right.
Yeah, but if they were, then that would have been great.
Okay.
Cool. So A5B. Awesome. And then now with numbers, I'll go ahead and let you guys try this one. I'll do 2 minutes, I think. That's probably enough time. Okay. So how did you guys feel about that one?
Honestly, I'm a little lost with these ones. I I can't remember how to do them. I've been studying the other stuff. I haven't quite got to this part of the textbook yet. But I still give it a shot. I still have -3 to the 2nd power over 2 to the 2nd and 1 to the 3rd.
I got 9/4.
Cool. So we can go ahead and walk through this really quickly. So we can take this term by term. Every single thing is getting multiplied or divided. We can do this term by term. So this first term, what does that go to? Or
9.
9. Mhm. And then what about this second term right here?
-3.
That would become 1 under 1/1.
Yeah, so if we think about it,
Right.
if I was just to isolate this term, I'm going to move to a different color so I can draw in the purple. So my -1 over 3 is equivalent to 1/1 times 1 times 1. As you can see in the top corner. Or, sorry, let me add my negative. Because all I've done here is I've moved this term down to the bottom and then made that 1/1 to the third. And then anytime 1 is to an exponent, it's just 1 times itself. So it's always equal to 1. So
Right.
technically this term just goes away. It's still there because you're multiplying everything by 1, the top and the bottom, but you don't have to process it at all. So if we
Right.
wanted to, we could just put 1 down here for that term. All right, and then what about this one?
4.
So then we just get 9/4.
Okay.
Hopefully that makes more sense.
Yeah.
I just want to make sure the 1 is times 4, because when I move it to the bottom, because that'd be timesing it on the top, I times it on the bottom, correct?
Yeah, so either way, we can typically what I would do is I would move all of my different negative exponents to the other side, right? So I'd move this whole term down here. And if I had a -2 to the -2nd, I'd move that up here and then it'd become -2 just a second. That's typically the first step I would do before I process any other numbers. Is that all right? I guess there we go.
Yeah, that makes sense now.
Great, yeah, because you may or may not have that on your exam, but you definitely had it on your quiz. All right, so we're gonna go ahead and move on to systems of equations. Just conceptually, I'm gonna describe this because I think quite a few people were confused on the quiz. But when we're doing a 2x2 system of equations, the goal is to create 2 linear equations that relate 2 variables to 2 conditions. So, and then once we have that, we can solve it using typically the substitution method is used in this class, but eventually you may learn the elimination method if you haven't already. So the substitution method, you just take 1 variable from the first equation, and then you solve it for an A and everything else on the other side, and then you substitute that into the second equation, plug in your variables, and then you should be able to find both of your variable answers. There's also special cases where you have infinitely many solutions. This means that you can't solve a variable and you get a constant equal to constant. So a 7 equals to 7, like we had in our other quiz. So whatever you plug in for one variable in both equations, you'll get the same thing for A. Just like we had it in example, or in quiz 5, there's also a case where we get no solutions, where the system contains 8 parallel linear equations. So they will never intersect because they have the same slope. So really quickly, we're going to go ahead and do this one. If you know the elimination method, this one will be quite easy. And we'll go ahead and, I think, do you guys want 3 minutes?
Yeah, that'd be nice.
I'll give you 3 minutes. That's so loud. Sorry. All right, welcome back, guys. Were we able to solve this?
I hope so. Let's see.
I have no solutions.
Okay, I don't know what I'm doing then, I guess.
Actually, so let's go ahead and do this. So it is a special case. So hopefully both of you guys figured that out. This sounds like you did. Which equation would you like to start with first? With our, let's call this equation 1. Let's call this one equation 2. There we go.
I simplified or whatever, got the y variable for the first equation.
Yeah, I did too.
So you got, so you went 2y is equal to 10 minus 3x, and then divided both sides by 2. Is that what you guys got?
Yeah.
Yes.
And then we're plugging that into equation 2. So then we get 6x plus 5 3 has x is equal to 20. Is that correct?
Yeah, I realized where I went wrong. I wrote a 10 for some reason instead of a 5.
Yeah.
Okay, that was dumb.
No worries, it always happens. That's why whenever we take exams, we gotta take a deep breath and just go ahead and take it slow. So then we get 6x, and then we have to distribute, right? So we get 20, and then we get 8 plus 3 over 2.
36 as well, right?
7x.
What was that?
Oh, 7x. I just changed it into a whole number.
Cool.
Yeah,
And what'd
because
you?
4 times 3 over 2 is 6, I think. That's what it was.
Yeah, 6x.
Yeah.
All right, so then now we have 6x minus 6x, which goes to 0. Those two terms go to 0, and then we get 20 is equal to 20. So when we get the constants that are the same, that means which of the two cases do we have?
No solution.
It's infinitely many solutions,
Or infinite,
actually.
right? Infinite.
Yeah,
No
so if,
solution would be
Where did
0 equals 20.
yeah, if we had like this, then that would be no solution.
Okay, right.
Yeah. So continuing on with that, every single line will always intersect, so they have infinite solutions. So I guess using our elimination method, right? So one thing that we can think of, if you don't think of this, don't worry, it's just another way to look at it. If you look at our equation number 2, if we divide every single term by 2, and because we're doing everything the same to both sides, this is okay to do, at least to look at it, right? So we'll get 3x plus 2y is equal to 10. And then now you can recognize that those are the exact same equations.
Right. I forgot that you can do that.
Yeah, so that's just another you to double check. Fantastic. So how to make a 2x2 system of equations. Your goal is to relate the two variables to the two equations using, two variables to do different equations using two conditions to use with two equations. So like in quiz 5, where our two variables are apples and bananas, so we have apples and bananas, and then we wanted to relate it to an amount of money and the number of fruits that we want. So we can create a relationship between these two variables with this condition, and then these two variables with a different condition. And that's what kind of allows us to create the system of equations and do that relationship. So similar to quiz 5, if we have our apples costing $1.20 each, and our bananas costing 50 cents each, and I want to spend $9 on this week's fruit, and I want to have 11 pieces of fruit, what would the two equations be?
So one would be a plus b equals 11, right?
Yes, let me get a better color. And then what about our second one?
The next one would be 120a or 1.20a plus 0.5b. equals $9.
So then now solving these, so we've got our money condition and our fruit condition, right? Those match up. I guess this will walk you through it, but we can also do it ourselves if you'd like.
Yeah, I prefer so I can just get a good handle on it.
So what would your first step be? If you were to approach this, what would you want to do first?
I'd want to get B or A on the other side. That first side, just subtract either one.
Yeah, which one would you like to solve for?
Let's just do A for now, I guess.
Okay. For which equation do you want to start with? For our money or our fruit?
Let's do our fruits.
Okay, so you want to solve for A is equal to 11.
Just B.
All right. So I'm going to call this equation 3 for simplicity's sake. Now what do we do now?
We put an A spot on the second equation. So it'd be 1.2 in parentheses 11 minus B plus 0.5 B. And then just distribute from there.
All right, and then what do we get?
I can't do decimal math in my head, to be honest.
That's all right. I think it's
13.2
there we go. 13.2
minus 1.20 B plus 9. Okay.
Okay, and I don't think you'll be required to do decimal multiplication, so don't worry because you don't have a calculator, right? So then
Okay.
what's our next step?
Combine like terms.
So then what do we get here?
It's going to be 13.2 minus 0.7. 0.7 B.
Okay.
Or hold on. Just making sure I did it right.
It's
Yes.
yeah, that's right. So
And
then
now,
now what?
oh, sorry.
Go ahead.
Now I just subtract 13.2 from both sides.
Okay.
And we'd get negative 4.2, and that's on the right side.
And then what do you do to get B by itself?
Divide.
Okay, by negative 0.7 to both sides. And then what do we get?
Negative 6.
Is it negative or positive?
Positive, right, because it's both of them are. Sorry, I was doing it on my phone. I forgot to put
Nope.
positives on both sides.
You're
Or
good.
negatives on both sides.
So what's the next step?
Plug B in to the second equation.
Okay. Do you want to plug it into the second one or the third one?
The third one?
Yeah.
Oh,
Yeah,
I guess we
'cause-
could do that too, yeah.
Yeah, because we already solved for A, might as well make it easier. So in equation 3, A is equal to 11 minus 6.
That give us 5.
All right, so we have 5 apples. And we have 6 bananas. Any questions?
Nope.
All right. So the slides just walk you through all of it. So in case there are questions, you can go ahead and look at this. And yeah, that's pretty much all I have prepped for you guys. Oh, ignore that. This is the second review session. I do have office hours on next Monday. So if you guys have more questions, I can answer those there. Or if you have any specific ones we can work together that you want to bring in and up right now, we can do that too. I also have some take-home problems. If you guys would like to take a look at these, we could as well. We can go ahead and practice these because we have extra time.
Yeah, sure. I'm okay with that. Which one do you want us to practice, or do we just choose?
It's up to you guys. Yeah.
Okay. I'll just do the first foiling one, I guess.
Let me really quickly just get some room. Cool. Okay. So I'll go ahead and just do it while you guys are as well. Did you guys finish this problem?
Yeah, I think was the foiling one just simplifying? Is that all it was?
Let's take a look. But did you get 3 for your slope?
Oh, sorry, I wasn't doing that one. I was
Oh,
doing
no worries.
the foiling one.
Cool. So look.
Okay, yeah, let's just simplify. Okay.
Yeah.
Well, I got negative 15x for the first simplify one.
I got negative 15x plus 10t.
10t.
All right. So
I see what I did wrong. I switched the negative to a positive.
Yeah, that makes sense now. I was like 10t, but yeah, that makes sense.
cool. So negative 15x.
Yeah.
Sounds good. And then the second one is more challenging for sure. So I'll give you guys some time to do that one if you'd like.
Oh, right. I thought for some reason that you were supposed to do it would be sx to the power of 2. Because we did see, I don't know if that doesn't work though.
Do we have any questions on this one?
No, I like I remember how to do it. I just forgot that it's not adding not it's not sx to the power of 2, it's 2sx.
Yeah, because we're just adding.
Right.
All right, and then let's see, graphing the function. Let me see if I have it still pulled up and right, I only give you 3 points instead of more than that. So you don't actually get that much information of how the graph is shaped. But it's still good practice to practice your x and your f of x. But I wouldn't expect you to know like if it was curved or straight from that data.
I would have guessed it's an absolute value.
Yeah. Let me show you actually what I graphed. Let's see, so let's put that here. This is actually, and I wouldn't expect you guys to know this at all because I didn't give you any information. This is a fun one called y equals 3x squared plus 3x plus 1. I just threw random numbers in and then took the points. But if I had given you a point at negative 1/4, then you should have been able to figure out that it was parabolic. But because I didn't, you could have guessed either way. Anyways, I just kind of made that one up pretty quickly. So no worries about that. Do we have any other questions?
No, I think it's been pretty good.
All right, any quiz topics or quiz questions that you guys got back and didn't quite understand?
No.
All right, have you guys done your formula sheets or at least started?
I've started my formula sheet.
Yeah, that's great to hear.
Are we only allowed to have formulas on that sheet, or just like, can we have any examples of anything?
You should be able to have examples.
Okay.
Yeah. There were no restrictions on it, and I've seen a lot of my tests that I get now are just like anything goes as long as it's like handwritten.
Okay.
Yeah. And then I've
Perfect.
also had I'm not sure the rules on this exam, but I've seen exams where you're able to write it on your iPad and then print that as long as you're like handwritten.
Yeah, I was going to ask that because that's what I'm doing. So
Yeah, that should be fine.
okay.
And
Perfect.
if it's not, tell them I told you. So I'll take the blame. Okay, cool. Well, as long as you have no other questions, I have nothing else prepared for you guys. So yeah, thanks for coming to the review. I'm gonna stop the
Thank you.
recording.